All right, so get ready to dish those heavy EJB textbooks because today we're going on a deep dive into a world of J2E development.
Oh, without?
Without EJB?
Okay.
I know it sounds crazy, but trust me, this is going to be eye-opening. We're cracking open Expert 101 J2E development without EJB by Rod Johnson and Jürgen Holler, and this book doesn't hold back.
No.
Just a heads up, this book is for seasoned J2E folks, so if you're still kind of figuring out Java basics, you might want to bookmark this one for later.
Right, yeah. The authors really shake things up. They challenge this whole idea that EJB is like the heart and soul of J2E. Instead, they argue that while powerful, it can be like using a chainsaw to cut butter. Overkill.
Okay, so let's get this straight. They're saying that EJB, the technology that's been touted as the core of J2E, might actually be holding us back.
That's exactly what they're saying.
Wow.
They point out that all that complexity that comes with EJB, it can actually make you less productive.
Oh, interesting.
Think about it. Instead of, focusing on writing elegant business logic, you're wrestling with these clunky APIs and mountains of XML.
Yeah, I've definitely been there, staring at a deployment descriptor for hours, wondering if I'm in the right profession. But aside from the complexity, what are some of the other drawbacks they highlight?
Testability.
Oh, okay.
Testability is a big one. Imagine trying to unit test your EJB components.
Right.
You need a whole container up and running, which makes for a really slow and clunky testing process.
Right.
Not exactly agile, right?
So you're saying that with EJB, even simple unit tests become a major headache.
Yeah, exactly.
Right.
And they also kind of hint at this idea of lightweight alternatives to EJB.
What exactly are we talking about here?
Think of it as trading in your bulky hiking boots for a pair of sleek running shoes.
Okay.
Lightweight containers, like Spring, offer a much more streamlined way to build your J2E applications. They handle a lot of the heavy lifting, like managing dependencies and configuring objects, so you can focus on what really matters, your business logic.
So instead of getting bogged down in the EJB jungle, I can focus on writing clean, efficient code. Sounds promising. But how does Spring actually achieve this magic?
Well, one of the key concepts is inversion of control, or IOC.
Okay.
It's like letting Spring be your personal assistant. Instead of you having to manually wire all your objects together, you just tell Spring what you need and it takes care of the rest.
So I can essentially stop worrying about manually wiring all my objects together and let Spring handle that mess for me.
Exactly.
That sounds liberating.
And speaking of sleek solutions, the book also champions aspect-oriented programming, or AOP.
Okay.
It's a way to modularize those cross-cutting concerns like security and transaction management without cluttering up your core code. Imagine being able to add these functionalities with a simple declaration, like adding a sprinkle of magic dust.
So instead of weaving these concerns throughout my code, I could just sprinkle on some AOP and keep my business logic nice and clean. Now that's efficient. But hold on. Is this book suggesting that J2EE is basically all wrong?
Not necessarily. They make a really crucial point.
Okay.
J2EE is a rich ecosystem.
Right.
And EJB is just one way,
Okay.
and often not the best way, to tap into its power.
They're not just throwing shade, though, right?
No.
They actually back up their arguments with real-world examples.
Absolutely.
Sure.
They analyze well-known J2E applications, comparing different architectures to show how a lightweight approach can be more efficient and easier to manage. It's like seeing the before and after photos of a home renovation.
Right.
The difference is striking.
So they're not just talking theory, they're showing us how these concepts play out in the real world.
Exactly.
And the underlying message seems to be, keep it simple.
Exactly.
Okay.
They emphasize that complexity breeds bugs, increases development time, and makes your application a nightmare to maintain. It's like building a house of cards.
Right.
Sure, it might look impressive, but one wrong move and the whole thing collapses.
So the takeaway here is think twice before jumping on the EJD bandwagon.
Yeah.
There might be a simpler, more efficient path to J2E enlightenment waiting for you.
Exactly. And remember, as the authors emphasize, the simplest solution that meets your needs is often the best solution.
Okay.
Don't over-engineer just because you think you need to use EJB.
Now, they don't just throw shade at EJB and leave us hanging, do they?
Right.
What kind of alternative architectural paths do they propose?
They delve into 4 key architectural choices you face when building a J2E application.
Okay.
First, there's the classic J2EE architecture, which is all about remote EJBs.
Right.
But they argue it's often a poor fit for web applications.
Okay.
Then there's the local EJB architecture, which improves on the classic approach, but still carries some EJB baggage.
And I'm guessing they're not big fans of either of those options?
Not really, no.
Okay.
They also talk about the ad hoc J2EE architecture where you skip EJB altogether. This can be effective if you're careful, but it's easy to fall into traps like hard-coded dependencies and a lack of structure.
Right.
And finally, the approach they champion, the lightweight container architecture.
Ah, so this is where Spring and IOC come into play.
Exactly.
Nice.
They advocate for using POJOs,
Okay.
plain old Java objects,
Okay.
as your business objects, managed by a lightweight container like Spring. Combine that with AOP for things like declarative transaction management,
Right.
and you've got a recipe for a much simpler and more maintainable application.
Okay, so they've laid out the problems with EJB and presented this intriguing alternative.
Yeah.
But what are some concrete examples of how this all works in practice?
Well, one of the most fascinating parts of the book is where they dissect real-world J2EE applications, like the Sun Java Pet Store and the Ibidis JPet Store.
Okay.
They compare and contrast different architectures side by side, showing the pros and cons of each approach. It's like having a front row seat to an architectural showdown.
So they're not just preaching from a theoretical pulpit. They're getting their hands dirty and showing us how it's done.
Exactly. It's not just theory. It's about putting these ideas to the test, and the results speak for themselves. You see how a lightweight approach can dramatically reduce code complexity, make testing a breeze, and lead to a much more flexible and maintainable application.
I'm starting to see the light here. This is like trading in a clunky, gas-guzzling car for a sleek electric sports car.
Right.
You get the same power and performance, but with a much smoother ride.
That's a great analogy. And speaking of performance, the book also delves into specific technologies that offer lighter alternatives to traditional EJB services.
Okay.
For instance, instead of relying on EJB for transaction management, you can use Spring's declarative transaction management,
Okay.
which is much simpler and more efficient.
So it's like getting the same functionality, but without all the EJB overhead.
Exactly.
Okay. And what about persistence? Are they suggesting we ditch EJB entity beans as well?
You bet. They argue that alternatives like JDO and Hibernate can provide simpler and often more powerful object relational mapping than EJB entity beans.
It's all starting to come together. Now they're painting a picture of a J2EE world where you can pick and choose the best tools for the job without being forced into the EJB straitjacket.
That's the beauty of it.
Yeah.
And it's not just about the technology choices.
Right.
They also highlight the importance of an empirical process, which means testing your assumptions and validating your architecture early on.
So it's like being a scientist in the lab, constantly experimenting and refining your approach based on real-world results.
Exactly. They recommend building a vertical slice of your application early on, which is like a mini version of your app that you can use to test your architecture and make sure it's going to work before you invest too much time and effort.
It's like building a prototype before you commit to the full-scale production.
Right.
It just makes sense. But let's be honest. One of the reasons EJB became so popular was this idea that you needed it for distributed applications. What do they say about that?
They challenge the assumption that you always need distributed objects for scalability.
Oh, yeah.
They argue that in many cases, a well-designed, co-located object model can be just as scalable and much simpler to manage.
So they're basically saying, don't overcomplicate things just because you think you need to.
Yeah.
Keep it simple, keep it local, and you'll be much better off.
That's a great summary. They also dig into a topic that's often a source of confusion.
Yeah.
The difference between components and objects.
Yeah, I've always struggled to understand the subtle distinction between those two.
They explain that while both concepts share some characteristics, they're not interchangeable.
Yeah.
A component is a self-contained unit of functionality that can be deployed and reused independently,
Right.
while an object is an instance of a class that encapsulates data and behavior.
So you could think of a component as a higher level abstraction than an object.
Exactly.
A component might be made up of multiple objects working together to provide a specific functionality.
Exactly. And they argue that while EJB focuses on the component model, a lightweight container approach can achieve many of the same benefits while still embracing the flexibility and power of object-oriented programming.
Okay, this is where my brain starts to hurt a little.
Yeah.
Can you give us a real-world example of how AOP can simplify things in a J2EE application?
Absolutely. Let's say you want to log every time a specific method in your application is called.
Fine.
Traditionally, you might have to add logging code to every single method,
Right.
which can be a real pain and make your code messy.
I could already see the copy and paste nightmare unfolding.
Yeah, with AOP, you can define an aspect that intercepts all method calls and injects the logging logic without modifying the original methods.
So it's like having a separate module that takes care of the logging, keeping your core code clean and focused.
Exactly, and that modularity makes your code much easier to maintain and extend. If you need to change the logging logic, you only need to modify the aspect rather than updating every single method.
Now, you mentioned Spring quite a bit. Are there any downsides to using Spring, or are they suggesting it's a silver bullet for all J2EE development?
They're not saying Spring is perfect,
Right.
but they highlight its many strengths,
Yeah.
like its lightweight container,
Right.
its support for AOP, its data access abstractions, its web MVC framework, and its seamless integration with other popular technologies.
So it's not a silver bullet, but it's a pretty darn good toolkit for building modern J2EE applications.
Exactly, and they provide a comprehensive overview of Spring, covering everything from configuring beans to leveraging its powerful AOP framework.
The book doesn't shy away from diving into the technical nitty-gritty,
Right.
but it does it in a way that's accessible and engaging, even for someone like me who's not a Spring expert.
Right, and one of the things they emphasize is the importance of choosing the right transaction management strategy for your application.
Okay.
They discuss the limitations of EJB CMT,
Okay.
pointing out that it can be overkill for applications that only work with a single database.
So if I'm not dealing with complex distributed transactions,
Yeah.
I might not need the heavyweight JTA
Yeah.
machinery.
Exactly, and they propose Spring's AOP-based transaction management as a more flexible and lightweight alternative, especially for those scenarios.
It seems like they're big fans of AOP. They keep finding new and clever ways to use it.
They show how you can use Spring AOP to declare transactional behavior using simple annotations, keeping your code clean and concise.
Okay, so we've covered a lot of ground here. We've seen how EJB can be overly complex and how lightweight alternatives like Spring can offer a more efficient and flexible path to building J2EE applications. But what about the data itself? How do they suggest we handle persistence without relying on EJB entity beans?
They delve into the world of object relational mapping, or ORM, which is all about bridging the gap between the object-oriented world of Java and the relational world of databases.
Right.
They discuss the pros and cons of various approaches, including JDBC, JDO, and Hibernate.
Hibernate. That's a name I've heard thrown around a lot.
It's a popular ORM framework, and the authors make a compelling case for why it can be a powerful alternative to EJB entity beans. They even provide concrete examples of how to integrate Hibernate with Spring, showing how you can achieve seamless persistence without all the EJB baggage.
So they're not just saying ditch EJB, they're giving us concrete tools and techniques for building robust and efficient data access layers without relying on the traditional EJB approach.
Exactly. And they don't stop there. They also emphasize the importance of caching for improving performance.
Caching, isn't that something you do with web pages?
It can be used for web pages, but it's also incredibly useful for database access.
Oh, okay.
Caching allows you to store frequently accessed data in memory,
Right.
reducing the number of trips to the database and speeding up your application.
So it's like having a shortcut for retrieving commonly used data. Instead of going all the way to the database, you can grab it from a closer, faster location.
Exactly. They discuss different caching strategies and explain how you can integrate caching into your Spring-based applications seamlessly.
Okay, so we've talked about lightweight containers, AOP, transaction management, ORM, and caching. It seems like they're covering all the bases here.
Right.
But I'm curious, what about remoting? Surely EJB is still necessary for building distributed applications, right?
That's a common misconception. The book tackles the topic of remoting head-on, exploring various techniques for accessing and invoking remote services.
Okay.
They discuss traditional RMI, JAX RPC, and lightweight HTTP-based protocols like Hessian and Burlap.
Wow, so many options. Are they suggesting that we can build distributed applications without EJB?
They're arguing that EJB isn't always the best or most efficient solution for remoting.
Okay.
They highlight the complexities of EJB remoting and propose alternative approaches that can be simpler and more lightweight.
I'm starting to think these authors have a serious vendetta against EJB.
It's not a vendetta, but they do present a compelling case for why EJB might not be the best choice for many J2EE applications. They encourage developers to carefully consider the trade-offs involved in each remoting technology and to choose the approach that best fits their specific needs.
So it's all about choosing the right tool for the job.
Right.
And sometimes that tool might not be EJB.
Exactly. And they highlight the flexibility of Spring, showing how it can be used to seamlessly integrate with various remoting technologies, whether you're using RMI, JAX RPC, or lightweight HTTP-based protocols.
Okay, so we've tackled architecture, lightweight containers, persistence, transaction management, and remoting. What else is there?
Well, they dive into a topic that's crucial for any enterprise application: performance and scalability.
Right.
They start with a discussion of instance pooling, which is a technique for improving performance by reusing object instances.
I remember hearing about instance pooling back in the dark ages of EJB. Is that still relevant today?
They acknowledge that advances in garbage collection technology have made instance pooling less critical for many applications. But it's still a valuable technique for certain scenarios, especially when dealing with resource-intensive objects like database connections.
Okay.
They discuss different pooling strategies, including shared object pools and thread local pools, discussing the pros and cons of each approach.
So they're basically saying don't just blindly apply instance pooling without understanding the trade-offs involved.
Exactly, and they explain how Spring provides a flexible and powerful mechanism, for instance, pooling, using its AOP framework to transparently pool target objects.
Always with the AOP, it seems like Spring AOP is the Swiss Army knife of J2E development.
It's certainly a versatile tool, and they show how you can configure and manage instance pools in Spring, giving you fine-grained control over their behavior.
They also delve into the often dreaded topic of thread safety.
Right. They explain why thread safety is crucial for any application that deals with concurrent access to shared resources. Outlining common threading issues like race conditions, deadlocks, and starvation, they discuss the importance of synchronization and locking mechanisms, and they highlight the benefits of using concurrency libraries for simplifying thread management.
So they're not just giving us the what of thread safety, they're giving us the how as well.
Exactly. They provide practical advice and concrete examples of how to write thread-safe code, leveraging Spring support for various threading models.
Okay, so we've covered a lot of technical ground here, but one of the things that struck me about this book is that it's not just about the technology, it's about challenging assumptions and promoting a more thoughtful and pragmatic approach to J2EE development.
Absolutely. They encourage developers to question the status quo, to think critically about the tools and techniques they're using, and to always strive for simplicity and elegance in their solutions.
And speaking of elegance, the book concludes with a fascinating discussion of how to achieve true object orientation in J2EE development.
Right.
Arguing that traditional J2E practices often compromise OO principles in favor of EJB compliance.
They introduce the concept of fake objects,
Okay.
highlighting how transfer objects and entity beans generated from database tables often violate core OO principles.
Fake objects. What do they mean by that?
They're referring to objects that look like objects on the surface,
Okay.
but lack the true characteristics of objects such as behavior and encapsulation. They point to transfer objects and entity beans as prime examples.
So they're basically saying that these objects are just data containers devoid of any real object-oriented goodness.
Exactly, and they argue that this reliance on fake objects leads to brittle code that is difficult to maintain and extend.
Right.
They advocate for a shift towards a more object-oriented approach, where domain objects are true objects with both state and behavior.
So it's about treating objects as first-class citizens in your architecture rather than just relegating them to the role of data carriers.
Precisely, and they demonstrate how lightweight containers like Spring can facilitate this shift.
Right.
By providing a framework for managing dependencies and configuring objects without imposing the restrictions of the EJB component model. They discuss the JAX RPC programming model, highlighting the steps involved in defining and deploying web services. And they also delve into the complexities of handling data types, exceptions, and other challenges specific to web services development.
Right. Building web services is rarely a walk in the park.
Definitely not. They also explore the WS specifications, a set of extensions to the core SOP protocol that aim to address issues like security, reliability, and transaction management in web services.
So it's like adding extra layers of sophistication to the basic SAP foundation.
Exactly, but they caution against overusing these specifications as they can add significant complexity and overhead.
So it's another example of their philosophy of keeping things simple unless you absolutely need the extra bells and whistles.
Exactly. They argue that in many cases, the core SOP protocol is sufficient for building robust and interoperable web services.
Okay, so they're giving us a comprehensive overview of web services and the challenges of building them, but I'm guessing they have some Spring-based solutions up their sleeves.
Of course, they wouldn't leave us hanging.
Right.
They explore Spring support for JXRPC,
Okay.
showing how Spring can streamline the process of creating and consuming web services, handling a lot of the boilerplate configuration and setup for you.
So Spring can be our trusty sidekick in the wild west of web services.
Exactly. And they also delve into lightweight HTTP-based remoting protocols like Hessian and Burlap,
Right.
which can be a simpler and more efficient alternative to SOB-based web services.
I've heard of Hessian and Burlap, but I've always been a bit intimidated by them.
They make them much less scary.
Okay.
They explain how these protocols work and highlight their benefits, such as their simplicity, their efficiency, and their firewall friendliness.
So they're like the lean, mean remoting machines.
And of course, they show how you can easily use Spring to work with Hessian and Burlap exporting and consuming services with just a few lines of code.
Okay, so we've covered a lot of ground in the world of remoting, but what about performance and scalability? Those are crucial considerations for any enterprise applications, especially in today's world of high-volume, data-intensive systems.
Absolutely. The book dives deep into performance and scalability considerations, starting with a discussion of instance pooling, a technique for improving performance by reusing object instances.
I remember instance pooling being a big deal back in the early days of EJB when object creation was a much more expensive operation. Is it still relevant today?
They acknowledge that advances in garbage collection technology have made instance pooling less critical for many applications, but it's still a valuable technique for certain scenarios, especially when dealing with resource-intensive objects like database connections.
Okay.
They explore different instance pooling strategies, including shared object pools and thread local pools, discussing the pros and cons of each approach.
So they're basically saying don't just blindly apply instance pooling, understand the trade-offs, and choose the strategy that best fits your needs.
Exactly. And of course, they show how Spring provides a flexible and powerful mechanism, for instance, pooling using its AOP framework to transparently pool target objects.
I like Spring is the gift that keeps on giving.
It's a pretty amazing framework. They also delve into the often dreaded topic of thread safety,
Right.
which is essential for any application that deals with concurrent access to shared resources.
Thread safety can be a real headache. It's one of those things that can be easy to overlook, but can cause all sorts of nasty problems if you're not careful.
They explain why thread safety is so important, outlining common threading issues like race conditions, deadlocks, and starvation.
Right.
They discuss the importance of synchronization and locking mechanisms, and they highlight the benefits of using concurrency libraries like Dougali's util.concurrent package for simplifying thread management.
So they're giving us a crash course in thread safety, covering the key concepts, the common pitfalls, and the best practices for writing thread-safe code.
Exactly. They also explore alternative approaches to thread safety, like creating a new object instance per client and using immutable objects.
So it's not just about locking and synchronization. There are other strategies you can use to make your code thread-safe.
Exactly. And they show how Spring can help you write thread-safe code by providing support for various threading models and concurrency utilities.
Okay, so we've covered performance, scalability, instance pooling, and thread safety. It feels like we've explored just about every nook and cranny of J2EE development.
Well, there's one more crucial aspect. They tackle web tier design and development. They emphasize the importance of building a thin web tier on top of a reusable business layer, arguing that the web tier should focus on handling web-specific logic, like request processing, response generation, and view rendering, while delegating business logic to a separate layer.
So it's about keeping the web tier lean, and meanwhile pushing the heavy lifting to the business layer.
Exactly, and they discuss the Model View Controller, or MVC, architectural pattern, explaining how it can help to separate concerns and promote code reuse, maintainability, and testability in web applications.
MVC is a classic pattern for building web applications. It's like the blueprint for a well-organized web app.
They then delve into the world of WebMDC frameworks, providing an overview of popular frameworks like Strut's WebWork 2 and Spring's own WebMVC framework.
Spring MVC, that's a framework I've been meaning to learn more about.
They do a great job of explaining how it works, highlighting its flexibility, its ease of use, and its seamless integration with the rest of the Spring ecosystem.
So they're giving us a taste of Spring MVC, showing us how it can be used to build robust and scalable web applications.
Exactly, and they don't just focus on Spring MVC. They discuss the strengths and weaknesses of other popular frameworks like Struts and WebWork 2, providing a balanced and informative comparison.
So it's about giving developers the information they need to choose the right framework for their specific needs.
Exactly, and they also emphasize the importance of integrating the web tier into the overall application architecture, avoiding tight coupling between the web tier and the business layer.
So it's about building a modular and loosely coupled system where changes in one part of the application are less likely to ripple through to other parts.
Precisely. And they delved into the challenges of building a reusable business layer, contrasting ad hoc approaches with more structured approaches, like using EJBs and lightweight containers.
I'm sensing a theme here. I bet they're going to advocate for lightweight containers.
You know them too well. They explain how lightweight containers, through their support for IOC and dependency injection, can simplify the process of creating and managing a reusable business layer, promoting loose coupling and testability.
So it's another example of how lightweight containers can bring order to the chaos of J2E development.
Exactly, and they show how Spring's web application context provides a bridge between the web tier and the Spring container, allowing web components to easily access Spring-managed beans.
It's like Spring is the glue that holds everything together.
It's a great analogy. They then take a closer look at request-driven web MVC frameworks, explaining their common workflow and highlighting the key steps involved in processing HTTP requests, dispatching to handlers, invoking business logic, preparing models, and rendering views.
So they're giving us a detailed walkthrough of how these frameworks work under the hood.
Exactly. They discuss the differences between controller-based frameworks like Struts and Spring MVC and command-based frameworks like WebWork 2, explaining how each approach handles controller instantiation and lifecycle management.
So they're giving us a comprehensive overview of different MVC approaches, highlighting their strengths and weaknesses.
Exactly. And they also explore different approaches to model and view handling, discussing the use of framework-specific form objects, command objects, generic Java objects, and different view technologies like JSP and Velocity.
So they're covering all the bases, giving developers the information they need to choose the right approach for their specific needs.
Exactly. They provide a deep dive into specific frameworks like Struts and WebWork 2, discussing their key features, their strengths, and their weaknesses.
So they're not just giving us a high-level overview. They're getting down into the details and providing real-world insights into how these frameworks are used in practice.
Exactly. And they conclude by reiterating the importance of building a thin web tier on top of a reusable business layer and highlighting the benefits of using a well-designed web MVC framework. They encourage developers to choose the web MVC framework that best suits their needs, considering factors like features, flexibility, ease of use, and integration with existing infrastructure.
So it's about choosing the right tool for the job and making sure it fits seamlessly into your overall architecture.
Precisely. And they showcase the power and flexibility of Spring's web MVC framework, highlighting its ability to support a wide range of web application development scenarios.
It seems like Spring is the recurring hero in this story.
It's certainly a versatile and powerful framework that plays well with others, and they also emphasize the importance of choosing the right view technology for your application.
There are so many view technologies out there. JSP, Velocity, FreeMarker, TimeLeaf. It can be overwhelming to choose the right one.
They discuss the pros and cons of different view technologies, helping you to make an informed decision based on factors like ease of use, performance, and integration with your chosen web MVC framework.
So they're giving us the guidance we need to navigate the sometimes confusing world of view technologies.
Exactly. And remember, this book came out before the rise of JavaScript-heavy front-end frameworks. It's fascinating to see how relevant their core arguments about simplicity and architecture still are.
Yeah, it's a testament to the enduring power of good design principles, no matter what new technologies come along. The fundamentals of building maintainable, scalable, and efficient software remain the same.
Absolutely. And they close the book by reiterating their vision for a more object-oriented approach to J2E development.
This seems to be a recurring theme throughout the book. They're not just advocating for specific technologies, they're advocating for a mindset shift, a way of thinking about software design that emphasizes simplicity, modularity, and object-oriented principles.
Exactly. They encourage developers to break free from the constraints of traditional J2E practices and embrace a more agile and object-oriented approach, leveraging the power of lightweight containers, AOP, and other modern technologies.
This book has been a real eye-opener. It's challenged my assumptions about J2E development and introduced me to a whole new world of possibilities.
It's a truly insightful and inspiring book that has had a profound impact on the world of enterprise Java development.
Yeah.
It paved the way for the rise of lightweight frameworks like Spring and helped to shift the focus from heavyweight, complex solutions to simpler, more agile, and more object-oriented approaches.
So the big question is, given the advantages of lightweight containers and AOP, how might these approaches influence the future of enterprise Java development? Would you be more inclined to consider alternatives to EJB now?
That's the million-dollar question. The impact of this book is undeniable. Spring has become a dominant force in the Java ecosystem, and AOP has gained widespread adoption, whether or not you completely abandon EJB. The principles of simplicity, modularity, and testability that this book champions are more relevant than ever.
This deep dive has given us a lot to think about. We encourage you to explore these concepts further and see how they can benefit your own J2EE projects. There's a whole world of resources out there, from the Spring Framework documentation to the vibrant online community surrounding AOP and lightweight containers. Happy coding!